All right, so today we're talking about electricity and physics. I already have some stuff written here, but I wanted to double check my number. And so we're talking about electricity. I'm just going to be talking about charges today. And so our charged particles that we work with, harkening from chemistry, are electrons and protons. Electrons are the negative charge, and so the electrons have a charge of negative 1.6 times 10 to the negative 19th coulombs. And coulombs is going to be the unit that we're measuring electricity in, and then a proton would be the same value except for positive because they balance each other out. Also, another thing to know, and we already kind of know this, but if we had two negative charges, they will repel each other. But if we have opposite charges, they will attract. And so that's going to be the basis for kind of what I show today. And I'm going to be drawing some metal balls and what happens. So if I have positively and negatively charged, if this one's positive and this one's positive, they're going to repel each other. If this one's negative, they will repel each other. If one's positive, one negative, they attract. That's cool, we get that. But if we introduce a balloon into the equation, and the balloon is negatively charged, what happens? Um, what's going to happen is we may see some attraction between the balloon and the metal sphere if the metal sphere is neutral. Because what's going to happen is the electrons of the metal sphere will move over to the opposite side that they can, because the electrons can move, but the protons will remain where they are. And so now we have these opposite charges and there will be attraction here. However, if we connect these with the conductor, these electrons will leave this one entirely and go over to the second sphere. So now the electrons are all hiding away as far as they can from the electrically charged balloon. Note that the balloon is not touching. And then there will still be the protons over here because the protons can't move, and we will still see this attraction. But if you remove the rod, the electrons still stay over here, and now this one's positively charged and this one is negatively charged. So if you wanted to get these having the same charge but opposite, that is a way you could do that. Also, another problem that was really interesting to me is if we have two positive charge here and four negative charge here, what if we touch it to something with a neutral charge over here? What would happen? And what we want to do is just split the electrons. Oh, we'll have two electrons over here and two electrons over here. That was my initial thought. But that's really not true. And then I also said that you'd move a proton over here. But then I'm like, oh, you can't move protons. These protons are going to have to stay, and they're going to want to have equal charges. So what will happen is this one will end up having three electrons and two protons with a net charge of -1. And then one of these electrons will go over here as well, having a net charge of 1. So they will have equal net charges, but that's because the protons can't move. So thinking about that protons can't move, electrons can move, and how that goes through. Also want to mention in a mole. In a mole, if I have 1 mole of hydrogen and it's neutrally charged, so that means that each one has 1 electron, we can calculate the charge of all those electrons because we have a mole, we can figure out the number of particles, and so we can find the charge we have based on that. So there's some electricity things in physics to know about. I hope that was helpful.